Hello everyone. Welcome to this next chapter. Here we are going to learn about what is a REST API. We are going to learn a lot of different things. We will first learn what is an API, then we will learn what is a web service, then we will learn what is a REST API in details, but we are not going to write code upfront on the first place. First, we will try to understand the theoretical details. So, what is a REST API? How does it work? How does the exchange of data happens between the client and server? And once we are thorough about it, then we will move on and we will learn about how to implement a REST API using Node.js, Express.js, VS Code, and it will we will learn it in the next chapter. And also we will learn what is SOAP API, why we have moved on from SOAP API to REST API, what is the difference between them. We will learn what are the different HTTP methods we use in the REST API. We will learn what are the different status code, like whenever you send request, you get a status code from the server. So how we define that, what are the meanings, and also we will learn about the detailed architecture of how the REST API works. So without wasting time, let's move on to our next lecture and we will see how does it work. Thanks for watching. See you. So an API is a set of rules and protocols that allows different software applications to communicate with each other. It defines the methods and data formats that applications can use to request and exchange information. APIs can be used for various purposes, including accessing web services, databases, or operating systems. APIs can be implemented in various forms, such as libraries, frameworks, or protocols. So basically, it's nothing but a set of rules. So to understand what is an API, let's take a real life example. Let's assume that I went to a pizza place to order some pizza. So let's say I went to the pizza place and I'm planning to order a pizza, but I don't know what pizza to take. So at that time, what should I do? So I will try to search if there is any menu where all the names and prices of the pizzas are mentioned. So once I have the menu, I will order a pizza. So the order will be taken by a waiter who is at the entrance of the pizza restaurant. And once he takes the order, he forwards that order to the kitchen. So once the pizza is prepared in the kitchen, then it will be sent back to the waiter and the waiter will send it back to me. So we can consider this as an analogy. So from the previous example or the previous analogy, what can we uh, finally conclude? So, so we can say that the user is a customer, right? The menu card is something using which we are sending a request. The waiter is the API and kitchen is the backend. Okay, so let's understand what is a web service now. So I guess you got an idea about what is an API from the previous video. Now, web services are a special type of API that specifically involves communication over the web using standardized protocols. Web services enable different software applications to interact with each other over a network. So we can see in the picture that it basically works in a network, and more specifically internet, and they use standard protocols like HTTP, HTTPS, XML, and JSON for communication. Uh, okay, so web services can be categorized into two main types: RESTful web services and SOAP web services. So you can see there are two main categories. One is a REST API and a SOAP API. So in summary, while all web services are APIs, but not all APIs are web services. Web services specifically refers to APIs that are accessible over the web and follow certain communication protocols. APIs, on the other hand, are broader concepts that encompasses various methods for enabling communications and interactions between different software components, which may or may not involve web-based communications. So that is the main difference between web services and API. So I hope you understand what is an API, what is a web service, and what is the difference between a web service and an API. Okay, so welcome to our next topic, which is the most awaited topic of this series, and that is a REST API. So, what is a REST API? So, REST API is the most important communication standard between computers on the internet. Okay, REST is a specific architectural style for designing a network application, and REST stands for representational state transfer and was created by computer scientist Roy Fielding. Okay, so what is the meaning of REST? What is the full form? So there are three distinct keywords which actually represent the REST API. So REST stands for representational state and transfer. These three words are heavy words. They carry a lot of internal meaning, technical meaning, and we will explore them later to understand the architecture of REST. How does it work? How the data is sent to the server? How the server sends back the data to the client? So everything is kind of hidden in these three words. So just for the sake of information, so I am giving you the picture with the person who actually invented REST API. His name is Roy Fielding, and he was a computer scientist. Okay, so in the context of REST API, the term was first coined by Roy Fielding in in the year 2000 as his doctoral dissertation, where he outlined the architectural principles behind the World Wide Web. So the name representational state transfer describes the fundamental concepts of REST, which is the transfer of representations of resources between the clients and the server. Here is the breakdown of what each part of the acronym means. So we will see what are the properties of REST. So these are the rules of REST. So REST should have uniform interface. There should be a client server communication. All the states should be stateless. Uh, Data should be cacheable. There should be a layered system, and there will be code on demand. So we will try to understand what these meanings of uh, each of the words are. So let's see what do they mean. So now, representational. So what is the meaning of representational? So representational means that the resources are represented in the format they can be understood by both the client and the server. This representation can be various formats such as JSON, XML, HTML, etc. There should be uniform interface. The meaning is, which is also a part of representational. The uniform interface is the fundamental to the design of any RESTful web service. It indicates that the server transfers the information in a standard format. The formatted resource is called a representation in the REST. This format can be different from internal representation of the resource on the server application. For example, the server can store the data as a text, but it sends it in a HTML representation format. The uniform interface imposes four architectural constraints. The first one is the requests should identify resources. They do so by using a uniform resource identifier. The clients have enough information in the resource representation to modify or delete the resources if they want to. Clients receive information about how to process the representation further. The server achieves this by sending self-descriptive messages that contain metadata about how the client can best use them. Clients receive information about all other related resources they need to complete a task. The server achieves this by sending hyperlinks in the representation so that clients can dynamically discover more resources. The word state basically means that the REST emphasizes stateless, which means that each request from a client to the server must contain all the information necessary for the server to understand and fulfill request. The server does not store any client state in between the requests. So all the sessions are stateless sessions. So for example, you can see that the request response cycle is a stateless. Okay, so now let's understand what is the meaning of transfer. The transfer refers to the exchange of representations of resources between the client and the server. This transfer typically occurs when the HTTP protocol using standard HTTP methods like get, put, post, and delete. Overall, the name representational state transfer encapsulates the key principle of REST, which includes a client-server architecture, statelessness, cacheability, layered system, and uniform interface, all of which contribute to the scalability, simplicity, and flexibility of RESTful APIs. So what is the meaning of client-server separation? By keeping the user interface separate from where the data is stored, we can make the user interface work on different platforms more easily and make the server simpler and more scalable. What is the meaning of caching? The responses to the requests should be marked as either cacheable or not. If a response cannot be cached, the client can save and reuse that data for similar future requests. What is layered system? The system is built-in layers where each part only interacts with layer directly next to it without knowing details of other layers. What is code on demand? REST allows clients to download and run code like applets or scripts to extend their functionality. When a client request is made via RESTful API, it transfers a representation of the state of the resource to the requester or the endpoint. This information or representation is delivered in one of the several formats via HTTP. So the formats can be JSON format, which is JavaScript object notation, or HTML format, or XLT format, or Python, or PHP, or via just plain text. Okay, so in case of REST API, generally we use JSON which is the most popular file format to use. But why JSON is the most popular file format? So it is the most popular file format despite of its name, because first of all it's language agnostic, and second, it's readable by both human and machines. Okay, so I hope you got an understanding of what is the internal architecture of a REST API. How does it work? What are the important technical aspects of a REST API? Now, what are the benefits of a REST API? So, REST API includes three benefits. The first one is its scalability. Okay, so what is the meaning of scalability? So systems that implements REST API can scale efficiently because REST optimizes client server interactions. Stateless removes server load because the server does not have to retain past client request information. A well-managed caching partially or completely eliminates some client-server interactions. All these features support scalability without causing communication bottlenecks that reduce performance. The next one is flexibility. So, what is the flexibility that we can get from the REST API? So RESTful web services support total client server separation. They simplify and decouple various server components so that each part can evolve independently. Platform or technology changes at the server application do not affect the client application. The ability to layer application functions increases flexibility even further. For example, developers can make changes to the database layer without rewriting the application logic. Now, the third one is uh, independence. So let's see what does that mean. So REST APIs are independent of technology used. You can write both client and server applications in various programming languages without affecting the API design. You can also change the underlying technology on either side without affecting the communication. So these are the three main benefits: scalability, flexibility, and independence. Okay, so now we will have a little bit understanding of what is a SOAP web service or a SOAP API. So we don't have to need like too much understanding about SOAP because it is now kind of obsolete, not being used that much in the market. Mostly we have moved from SOAP to REST API, but just for understanding purpose, we should know what was SOAP and why we have moved from SOAP to the REST API. So SOAP is a simple object access protocol. It's a lightweight XML based protocol that is used for exchange of information in the decentralized and distributed application environment. You can transmit SOAP messages in a way that the applications required, as long as both the client and the server use the same method. So the current specification described only a single transport protocol binding, which is HTTP. Uh, the reason for moving towards a REST API from SOAP API is the processing of XML was slow, and REST API provides open schema. Okay, now let's try to understand what is the difference between JSON and XML. XML is primarily used in SOAP web services, and JSON is primarily used in REST API. So the difference between SOAP and REST API is basically the difference between JSON and XML, which is the format of the data which is exchanged. So JSON is a lightweight, easy to read, and easy to write. XML is used as a markup language with tags to define elements and attributes. JSON is generally considered more readable and easier to parse formations, where XML it may be more readable for humans due to its hierarchical structure and the use of tags. So parsing JSON is typically a faster and more efficient because it has a simpler structure and a smaller set of data types. Where on the other hand, XML parsing can be more resource intensive because of its complex structure and additional features like namespaces. So JSON is widely used in web development, especially in AJAX requests, where XML has been traditionally used in various industries, including data interchange between different systems. JSON is less extensible compared to XML, where XML is more extensible as you can add new elements and attributes without affecting the existing structure. So overall, we can say that in summary, that both JSON and XML have their strengths and weaknesses, and the choice between them often depends on the specific requirements of a project or the existing standards within a particular industry. So JSON is favored for its simplicity and ease of use in the web development, while XML may be preferred in contexts where extensibility and human readability are crucial. Okay, so now we will try to understand what is the meaning of status codes in a REST API. So HTTP status codes are standardized codes used by web servers to communicate the result of a client's request to the server. These codes help in understanding what happened with the request and provide a clear indication of success, redirection, client errors, or server errors. So each status code is a 3-digit number and is grouped into 5 categories, each with distinct meaning. Okay, so we will try to understand now what are the different HTTP status codes and what kind of meaning they carry. So before going into that, I would like to show you what is actually status code. So let's come here and see there is a website here. So I'll go to the S console. Now I go to the network, and if I reload this page, okay, and if I scroll up and if I click on any link on the left side below, I will see that there is a status code here. So this is basically what status code is like when we send a request to the server from the client, how the server handles that request, and based on the request what kind of response it sends back. So it is the status of the response, whether the response has been successfully received or there is some kind of problem, there is a redirection, some errors. So everything is mentioned in the status code. So while writing code, we generally deal with this status code. So if the status code has certain value, then we do some particular actions. So now let's come back to our video. So let's see what are the different HTTP status codes. So as I have already mentioned, HTTP status codes are grouped into 5 different classes. So one XX, so anything that starts with 1, like 100, 101, 102 and all that, that is informational. So it gives us some information about from the server side. Something like 200, like 200, 201, these are related to success. Okay, so we will see in details. 300 related to redirection, 400s are related to client error, and 500s are related to server error. So let's see one by one. So if it is 100, so this status code means that the initial part of the request has been received by the server and that the client should proceed with the request or ignore the response if the request has already finished. So that is the meaning of 100. Then let's see what is 101. 101. So 101 is a for switching protocol status code. It means that the server understands the upgrade header field request and indicates which protocol it is switching to. Okay. Then next we will see 102. 102 is for the processing status code. It means that the server has accepted the full request but has not yet completed it, and no response is available as of yet. Next, we will see 103. The early hint status code is intended to be used to allow the user agent to preload resources while the server prepares a response. It is intended to be primarily used with a link header. The next one will be the 200 status code. So 200 status code indicates that the request was successful and the server has successfully processed the request and returned the requested resource. So we have just now saw in the Google response. The next one is 201. So this code is typically returned after a successful post request to create a new resources on the server. So when we are performing some kind of CRUD applications and we have created a new record in the server database, then we will get a response with the 201. It indicates that the resource has been created due to the request. Now 204. This code is returned when the server successfully processed the request, but there is no content to send in the response. It is commonly used for delete or put request. Next one is the 301. This code indicates that the requested resource has been removed to a different location permanently. The client should update its bookmarks or links to point to the new URL. So 400s, this code indicates that the server cannot understand the client's request due to malformed syntax or other client-side errors. So if the request what I'm sending itself is wrong, then it comes under the umbrella of 400 related errors. Then 401, this status code indicates that the client's request lacks valid authentication credentials or provided credentials are invalid. 404, this code is returned when the requested resource is unavailable on the server. So we see this error most of the time. 500, this code indicates that an unexpected error occurred on the server while trying to fulfill the client's request. And this is possibly the last one. This 503 code indicates that the server is temporarily unable to handle the request. This can be due to server overload or maintenance. Okay, so the last topic in our REST API tutorial will be the HTTP methods. So we'll know what are the HTTP methods. So HTTP is the foundation of data communication on the World Wide Web. It is a protocol defining how requests and responses should be formatted and transmitted between clients and servers. HTTP is essential for the operation of websites as it enables the exchange of various types of data, including text, images, videos, and more. HTTP operates a request response protocol where the clients initiate resource requests and server respond with the requested data. HTTP methods, also known as HTTP verbs, are essential to the HTTP protocol. They specify the type of action that should be performed on a resource identified by a URL. Each HTTP method has a specific purpose and behavior, and they define the operations that can be performed on a server's resources. Here are some of the most common HTTP methods. Okay, so let's talk about some of the most important HTTP methods and what are their usage. So first of all, what are the HTTP methods? Each HTTP method has a specific purpose and behavior. They define the operations that can be performed on the server's resources. So the GET method is used to retrieve data from the server. When a client sends a GET request, it asks the server to return a representation of the specific resource. GET requests should only retrieve data and not modify any server state. They are idempotent, meaning that the making the same GET request multiple times should yield the same result. The next one is POST. The POST method sends data to the server to create or update a resource. The data sent in the request body is typically used to create a new record on the server. Unlike GET, POST requests are not idempotent, as making the same request multiple times could create multiple records. PUT. The PUT method is used to update or create a resource on the server. It is idempotent, meaning that sending the same PUT request multiple times should have the same effect as it sending it once. When a client sends a PUT request, it specifies the complete updated response of the resource. The next one is the patch method. The patch method is similar to PUT, but it is used to make partial updates to the resources. Clients can send a patch request to update specific resources fields without sending the entire updated representation. Like PUT, patch requests are also idempotent. The next one is the delete method. So the delete method is used to request the removal of a resource from the server. It is used to delete a resource identified by the URL. Delete requests are idempotent, meaning that sending the same request multiple times should have the same effect as sending it once. The next one, the head method is similar to GET but retrieves only the headers of a response without the actual data. This can be useful to check for resources existence or retrieve metadata about it without transferring the entire content. The last one is the options, and the options method requests information about the communication options available for a resource. It allows a client to inquire about the HTTP methods supported by the server for a specific resource. So that's all about all the HTTP methods that we use for building a REST API. Thanks for watching. Bye bye.